All right, y'all, we're going to go ahead and solve an equation in which we have an inverse variation and a linear equation. This is a little bit more complicated than what we've been doing. So look at that side where it says 4 over x. We're going to want to get that x out of the denominator. So I'm going to multiply by x on both sides. And when I do so, what's going to end up happening is that the x's are going to cancel on that left side. And then we're going to be left with 4 equals to parentheses, which is our binomial set there, which is 3x plus 1 times x. Once I've got that, I am now going to take that x and I'm going to distribute it in. So we'll get the 4 equals to 3x times x, which is 3x squared plus 1x. Now, how is it that we solve a quadratic? Notice that x squared. Well, if you remember, we've got to set that equation equal to 0. So I'm going to subtract that 4 over. And when I subtract that 4 over, we're going to be left with 0 equals to 3x squared plus 1x minus 4. All right, so now that I've got it set equal to 0, how do I solve it? The easiest way, quickest way, in my opinion, we're going to factor this thing. We're going to at least check to see if we can factor it. And yes, this one is factorable. So let's go ahead. I'm going to draw the area model. And then I'm going to begin filling in the area model with what I've got. So if you remember, factoring with an a value, meaning that there's a number in front of x squared, I'm going to take that 3x squared. I'm going to put it right here in that box. I'm going to put a minus 4 right here in this box. And then what I'm going to do is I'm going to take that middle number, 1x, and put it right here on the outside. And the reason why is this number plus this number, they need to add to 1x. So when we figure that out, the other thing we need to do is multiply 3 and negative 4, which is negative 12. Okay, 3 times negative 4 is negative 12. And what we are going to do is we're going to look for the two numbers that multiply to negative 12, but then they are going to add to this 1x right here. Okay, so that's supposed to be an x. So 1x. So now let's go through a list. I know 1 times 12 is 12. I know 2 times 6 is 12. And I know 3 times 4 is going to be 12. And then all I have to do is make one of them negative. Doesn't matter which one negative. And one of them has to be negative in order to get the negative 12. And then what that I have to do is figure out which ones will add to that positive 1x. Okay. So if I do 1 times negative 12, it'll give me negative 12, but I'm not going to be able to get a positive 1 out of that. If we look just a little bit closer, we can see, well, 3 times 4, if I make the negative 3 times 4, that would be negative 12, and negative 3 plus 4 will give me a positive 1. So I'm going to use the negative 3 and the 4. So I'm going to write, okay, well, let's write 4x here. Let's put negative 3x there. It doesn't really matter where I put them in that, in what order. And then what I'm going to do is I'm going to begin the factoring process. So let's go ahead and let's say, all right, out of 3x squared and 4x, the only thing I can take out is an x because 3 and 4 don't have a common multiple. So x comes out, and then I'm going to say x times what is 3x squared? That is 3x. Okay, and then I'm going to keep working at x times what is 4x? Well, that'd be positive 4. And then I'm going to do the same thing. 3x times what is negative 3x? Well, that would be negative 1. So that gives me my binomial sets. 3x plus 4 is one of them. The other set is going to be x minus 1. And I'm going to set it equal to 0. All right, so now they're set equal to 0. So we're essentially back at this same part right there, except it's just written in factored form. So what we want to do now is we just want to solve for x by setting both of those binomials equal to 0. So I'm going to write 3x plus 4 equals to 0. And when I do that, it's going to give me x equals to -4 thirds. We're going to subtract the 4 over and divide by 3. And then I'm going to say x minus 1 equals to 0. I'm going to get rid of that -1. I'm going to add the 1 over. And that gives me x equals to +1. Okay, so our answer should be 1, and our answer should be -4/3. So how do we check it, just in case? We go over to Desmos. I'm going to check my work to make sure all my algebra is as beautiful as I think it is. And when I do that, I'm going to type in my two functions. If we look at the original functions, was 4/x, 3x plus 1. I'm going to look for where they intersect at. So notice that the first one is at x equals 1. That was one of our answers. Okay. And then the second answer is at -1.33. One of our answers was -4/3. So I'm just going to go ahead and type in -4/3. That gives me -1.33. So -1.33, +1. So we have two answers. This lines up and that lines up. That means we have done this correctly. All right, y'all, that's how we do this algebraically. I hope that helps.